Welcome everyone to our lecture on the topic of laws of motion. So, like in the last lecture, we discussed the ideas that when a block is kept on an incline, then how do we draw forces on it, and what are the angles which the gravitational force makes with the normal, and how do in general approach those questions. So in the last of the questions we discussed that that there is a block, and the block is experiencing some force, that is 10 Newton force, and the angle at which that force was acting was 30 degrees. So how do we resolve the forces? So that all basics that we have learned, that to resolve them in x direction, y direction, and then how to take the components. So let us do this question. So in this particular question, we have a block. The block is kept on an incline. So we are asked that the mass of the block is given as some 0.5 kg, and the incline is smooth, and the angle of inclination is given to us. So we know that, let's say, if the angle of inclination is some theta, then the angle with the gravitational force makes with the normal is also going to be theta. So the component of gravitational force, the first option is that the component of weight along the incline is dependent on the mass of the block. So for that, the answer would be correct, that the component of weight along the incline would be mg sine theta. We know the component of gravitational force along the line, along the common normal, or along the line in which theta is present, is cos theta, and the other component is mg sine theta. So definitely the component of gravitational force along the incline is dependent on mass. So that point is correct. Second point, the component of weight perpendicular to the incline is independent of the mass of the block. So the component of the gravitational force along this common normal line or perpendicular to the incline is independent of the mass of the block. So we are clearly seeing that it is dependent on the mass of the block. So this option would be incorrect. The acceleration of the block is dependent on the mass of the block. Again, we know that the acceleration of the block simply comes out to be a value called g sine theta. So the acceleration of this block is definitely independent of the mass of the block. It would be, even if there would be some roughness on the surface, even in that case the acceleration would have been independent. If the block on the smooth incline is having an initial velocity in upward direction, then its acceleration will not be g sine 30 degree. So if the block is initially moving in some upward direction with some initial velocity, then it should not alter the acceleration of the block. The acceleration of the block is simply governed by the forces acting on it, which do not depend upon the velocity. And by that we mean saying is that the velocity of the block does not change the acceleration of the block. It's the other way around, that the acceleration changes the velocity of the block. So this option is also incorrect, that the acceleration of the block is not g sine 30 degree. It would be g sine 30 degree only, because theta, the angle of inclination in this case, is 30 degree. So that's why. Next, let us say you have an incline, and like this, what this figure means is that that you have to, how do we take the angles that the weight makes with the normal. So the angle of inclination, if the angle of inclination is theta, then the angle which the weight makes with the normal is also theta, that is 30 degree. And how to resolve the components of gravitational force perpendicular to the incline and along the incline. So why we are emphasizing on this fact repeatedly is because that whenever we are dealing with such questions, then the components of the gravitational force, we should be quick in writing them, because there are a lot of other complexities usually in the questions involved. So these things should be a little bit easier for us to get to. So like it is written in the figure A. Figure A shows the angle between the gravitational force and normal, and figure B shows that dissolving the weight along and perpendicular to the incline. Any component of weight is dependent on the mass. The acceleration independent of mass and of the initial conditions. That is whether the block initially moves up or down. So that is what we were saying. That is pretty good to remember, that whether the block is moving up or down, or whatever the motion of the block may be, the acceleration of the block is not going to be affected. So let us do this question number 2. Question number 1: in the adjoining figure, the mass n hangs from a vertical thread which is further connected to horizontal string A. So this mass is hanging from this thread. It is being said that this thread is vertical, and these are the two strings to which it is connected to, string number A and string number B. So we would be supposed to find, we have to draw the force diagram of the block and the point P and determine the tensions in strings A and B. So for the block, it should be pretty easy to draw the diagram, since only gravitational force and tension are acting on it. So for the block, the tension in this vertical stringlets, that is T, and the gravitational force on the block, that is mg. So we can easily say that tension in the vertical string is equal to mg. Since these two forces would balance out, the net acceleration of the system is 0. For point P, if we were to draw the figure, so that is what we are looking for. To draw the figure of point P, now P is a massless point, because of which the net force acting on P should be 0. So the tension exerted by any string should be along the string. So due to B, it should be along B. Let's say this tension is TB. Due to A, it should be along A. Let us say that is some value TA, and the tension due to the vertical string, that would be along this vertical and vertically downwards, so that would be T. We know that the tension makes an angle theta with the horizontal, so this angle would also be theta. So again, applying Newton's second law at this point P, we can say that sum of forces in x direction is 0 and sum of forces in y direction is 0. Usually when we are talking about random points on string which are not accelerating at all, or which are massless, then the sum of forces on that point has to be 0, just because they are massless or just because they are having no acceleration. Even if a point has an acceleration but it is massless, even in that case, the sum of forces on it would be 0, because sum of force is equal to mass times acceleration. So as the mass becomes 0, that means that the RHS of the expression F equal to ma becomes 0. So in x direction, the forces which we are acting is T cos theta, and that is equal to TB cos theta, and that is equal to m into acceleration, which we are saying 0, which is basically the value 0. But this is not the only force acting in the x direction. There are other forces also. If we notice carefully, the tension TB cos theta is acting towards right and TA is acting, let's say this is positive x direction and TV cos theta is acting towards right is positive x and TA is acting towards left, that is negative direction, and sum of this should be 0. So TV cos theta should be equal to TA, and we can say that TV sin theta, that is the component of TV in this particular direction, should be nullified by the tension in vertical downward direction. So TV sin theta should be equal to T, but we already know the value of T. The value of T is mg, so that means tension in the string at point B is mg divided by sine theta. Similarly, we can find tension in the string A, that would be equal to mg sine theta, mg divided by sine theta into cos theta, that would be mg cos theta. So let us do the next question. So in the second question, we are going to apply an idea called Lami's theorem. So Lami's theorem states that if there is a point or there is a mass which is in equilibrium, and by equilibrium we mean that the sum of all forces acting on that body is 0. So in that case, if on that mass there are 3 forces acting on the mass, force number 1, force number 2 and some force number 3, the 3 forces acting on a mass, we know that sum of all forces acting on the mass is 0, and this angle is alpha, this angle is beta, this angle is gamma. So F1 divided by sine alpha is equal to F2 divided by sine beta is equal to F3 divided by sine gamma. So if we know that the sum of all these forces is already 0 and there are only 3 forces acting on the body, so in that case we can write a simplistic relation if we know the angles alpha, beta and gamma, and obviously the 3 forces have to be coplanar. So we would say that F1 upon sine alpha is equal to F2, and how to write or remember this expression, just simply write force F1 and divided by the sine of the angle opposite to that force. Similarly, force F2 and the sine of the angle opposite to that force, F3 and the sine of the angle vertically opposite to that force. So this is the way of writing Lami's theorem. So this can be used sometimes in solving some questions. So if we have a block and there is a force acting on the block, let's do the question number 2. So in question number 2 we have a block, it is tied to 2 strings. String number 1, let us say this string would have some tension T1 and string number 2 which would have some tension T2. Then you have to find the tensions in the string. So the block is tied to 2 tensions T1 and T2, 2 strings T1 and T2, and the block is in equilibrium as a string are tied. So they have to figure out what is the tension forces acting in the strings. So the important thing which we are doing here is that we are not this time taking the components in solving this question. So if we were to take the components in solving the question, we would take the x-axis and we would take the y-axis and then we would take the components and then write the equation sum of force in x direction is equal to 0. sum of force in y direction equal to 0 and so on. But we want to avoid that altogether this time, and we want to use this new idea. So we know that this angle is equal to some alpha and this angle is equal to beta. So this angle is equal to some 90 degrees, so we can easily figure out what these complete angle would be. And if we are to write the expression for this idea, then we would say that T1 divided by sine beta plus 90 degree would be equal to T2 divided by sine alpha plus 90 degree is equal to the weight of the block mg divided by sine by t minus alpha plus beta. So T1 divided by sine beta plus 90 degree. So that would be cos 90 degree, cos beta, as sine is positive in second quadrant. And that would be T2 upon cos alpha is equal to mg divided by sine alpha plus beta. From this expression we can write T1 as mg cos beta divided by sine alpha plus beta. And similarly we can write the expression for T2. So as you can see, we avoided a lot of calculations by using this particular theorem. So this is something which we can be used sometimes, but not always. So let us do the question number 2. Second question. So there is a incline which is smooth, and there are two blocks which are connected by a string, and there is a small pulley, as you can see here. So pulley does what is the job of the pulley? Its job is to keep this string in this particular shape and keep the things moving if they were to move. So we are given that the system is at rest, so nothing is moving. You have to find sine theta in terms of m1 and m2, and what is the force exerted by the incline on block m1. So we have an incline, and you have a pulley. So there is a block. The block is kept like this, and there is some angle of inclination. Let's say the angle of inclination is some theta, and the mass of this block is m1, and the mass of this block is m2. So what the string does is that it transmits the tension across it. Let's say the tension acting on the block m1 is T, then the same tension would act on this block m2. So that is what is the job of the string is. In addition to that, we are given that the system is at rest. So the gravitational force acting on the block is m1g, and we know how to take the components. What are the other forces acting on the block? The normal force, and the downward force acting on the block number 2 is m2g. So since the system is in equilibrium, we can think about this block first. So that is how we'll do these questions. That is, first we select the system. So we have decided the system. The system is mass block m2, and we would say sum of forces acting on M2 in one direction should be 0 since the block is not moving at all and not in acceleration. So upward force tension, that would be taken positive, downward force M2G, that would be taken as negative, and the sum of these two forces should be 0. That means the tension should be equal to M2G. Now we will write the equation of the block M1, and we would say that the component of gravitational force M1G along the incline, what would that component be? So that component would be equal to M1G sine theta, and that should be equal to the tension in the strength T. So from equation number A and equation number B, we must write that M1G sine theta is equal to M2G and M1 sine theta is equal to M2. So this is the equation which gives us the value of sine theta, and what is the normal force exerted on the incline. So we write a normal reaction minus mg cos theta. That should be the acceleration of the block in this particular direction, the component of mg in this direction. So we already know that they balance out. The n is equal to mg cos theta. So this is the force exerted by the incline on block number 1. Next question, that is the question number 4. So this is basically an extension of question number 3. Now there would be two inclines. Incline number A, which is having a mass m1, and incline number B, which is having mass m2. Again, we are given that the system is at rest and the pulley and incline are smooth. m1 upon m2 is to be found. So again, we will be drawing the inclines again, except in this case we will be drawing two inclines, and there is a single pulley which is able to balance out the weight of two blocks m1 and m2, which are making the angles alpha and beta with the horizontal. So this angle is alpha and this angle is beta. So this mass is m1, this mass is m2. We would say that the tension, again writing the equations, the gravitational force m1g and what would be its component in this direction. So let us say this particular direction is some x. So sum of forces in x direction should be 0 for mass m1. So we would say tension minus m1g cos sine alpha should be equal to 0. So this should give us tension is equal to m1g sine alpha. And for the second block, we will say that again tension is in upward direction, and the gravitational force is in downward direction, and its component would be some m2g sine alpha. So tension from that block, we would get tension is equal to m2g sine beta. So we can write that m1g sine alpha is equal to m2g sine beta. So with this g is cancelled out, m1 by m2 is equal to sine beta divided by sine alpha. The mass of the block m2 affects the reaction between m1 and m3 for the system to maintain or remain at rest. So there is a system which is drawn like this. This is the mass m1, this is the string, this is the mass m2, and this is the mass m3. So this angle is some alpha. So the question is that would m2 affect the relation between m1 and m3 for the system to remain at rest? So one thing which we have to learn from this particular question is that the tension in the strings they change when we have different strings. Let's say we have string number 1 and there is a different string. So the tension in the strings would be different. So this is the case. This should be the starting point with which we are doing any question. Um, in this particular question, we have to assume that the system is at rest. That is, we have to evaluate the whole system when it is at rest. So when it is at rest, and let's say we want to study the system M2, then we would say that the tension T1 should be equal to tension T2. So this is only the case when the block of mass M2 is at rest. Otherwise, we would always have to take the tensions in the strings unequally. That is, this tension would be T1, this tension would be T2, and they would be unequal. But the system is at rest and it has having no acceleration. That's why the tensions are coming out to be equal. That is equal to some value, let's say T. So again, now we are supposed to find the relation between M1, M2 and M3, whether what is the relation for the system to exist at rest. So as you see, as we saw in the last question, that the relation comes out to be basically affected by what are the components of the gravitational force which are responsible for moving the block. So the component of gravitational force, let's say this angle is some alpha. So this component is some m1g sine alpha, and this component which is trying to move the block in this direction is m3g. So we know these two components must balance out, and since m2 is not playing any role for system for m1 to remain at rest, t1 is equal to m1g sine alpha, and for m3 to remain at rest, t2 should be equal to m3g, but both of them are equal. So we can easily say that m1g sine alpha should be equal to m3g for system to remain at rest, and there is no play of m2 in determining that condition. So and that is what we should examine physically also, since m2g is not contributing whatsoever in moving the block to the left or the right, so it won't affect the condition for the system to remain at rest. The only factors which would be deciding whether the system would be moving or not are m1 sine alpha and m3, not even g would also cancel out. So this was this question. So in this lecture we'll be ending at this point with the questions. Again, we'll be taking questions in next lecture also, and as we have seen the application, we are slowly going moving towards more and more application of the problems. We'll be seeing that how these ideas are applied. So thank you for joining and have a great day.